All right, so this is CS1300, Introduction to Computer Science. Went over the syllabus with you guys last week, but a couple of things to remember. Everything is going to be turned in and coursed in. All of your assignments are going to be posted and coursed in. Coursed in is your place to go for everything great and grand about this class. The drop add date for this semester, this is the correct date. The one posted and coursed in right now on that PowerPoint is wrong. So the 16th is the last day to drop add. Textbook is free and online. I'm not taking late work unless you make arrangements prior to the assignment being due. I will take nothing late. Don't email me at 11:30 at night. Let's do it 11:59 and ask for an extension. That's not prior notice. This is absolutely an introductory course. You do not have to have any background in computer science to do this course. We are going to start at the very beginning and build our way up. Some of you that do have experience in computer science are going to be a little bored the first week or so as I introduce it, but I promise you it gets more challenging as we go. Getting help. This is also an updated slide. This is the hours for the CSX lab. So they have in-person and online tutoring available. If you're stuck or you can't get in touch with me because it's I'm in class or I'm not in office hours, you can go to them in person or online and they will be able to help unstick you and give you some advice and help you with your code. My email address is down here. I have office hours from 9:30 to 12 every day, Monday through Thursday. I don't have any office hours scheduled on Friday, but I'm happy to schedule individual times because the times do not match your schedules. I also do stream, well, not really stream, but I have a Zoom call, a Google Meet call open during my office hours usually. So if you're easier to catch me online, you can use the link for that. I think I posted it in the syllabus. If not, I will post it out in our announcements and discussions this week to make sure everybody has it. So let's get started. The computer science is, if you're new to computer science, it's a completely different way of thinking about solving problems. So there's a lot of different aspects and elements to it. If you look at our new course offerings and our new degree offerings, you'll see that now there's a lot of different specializations that even we're offering here at West Georgia. So you can do everything from programming to cybersecurity to web page development. There's all sorts of things you can do in computer science. We're specifically going to talk about programming in here because all the software you use, somebody had to program it. We're going to talk about problem solving and try to teach you guys how to break a problem down into its individual core components where you can build it back up as a program. So the first thing we are going to start talking about is problem solving skills, building what we call algorithms, try to come up with a solution or a plan for how we're going to accomplish tasks. The biggest thing that, in my experience, beginners tend to forget to do is define what the problem really is. So, you read it really quickly and you think, oh, I understand what I'm doing, but really you didn't look at the finer details of it. So save yourselves lots of hours of frustration and sit down and really go through the detail of the assignment or problem you've been given and look for the things that are going to trip you up, and we'll find details that you might not have thought about the first time you read through it. Thinking creatively about solutions is what I enjoy the most about computer science. There's no one correct solution. Very rarely is there only one way to solve a problem in programming and computer science. The way I solve a problem and do the labs and do the assignments may not look anything like the way you did it, but it's just as accurate and just as correct, as long as it gets the final results that you were looking for. This also frustrates some students, especially if they come from a discipline that's a very exact, precise discipline like math and some of the science fields, because they want a simple, or not necessarily a simple, but a precise and one set. Expressing yourself clearly and accurately is always something we're going to encourage you to do. You can write a lot of code that's not very clean and not very easy to read. That makes it very hard for someone to grade, but if you get into a professional field, it also makes it very hard for somebody on your team to work collaboratively with your code. So we're going to stress commenting your code, working with clean code, and trying to make sure you're organized and expressing yourself in a readable manner. You do need to verify that your solution works correctly. Don't test it once and say, oh, that worked. You need to test it multiple times with different input and different data, because it might work for one set of data, but not work accurately for all sets of data. So we're going to start off by building algorithms. Algorithms are basically a combination of English and what we call pseudocode on paper, solving computing problems. And everybody's going to go, this is a computer class. What do I need paper for? Okay, do it on a computer, but you still need to do some planning before you start coding. Usually an algorithm, the simplest definition of an algorithm is step-by-step instructions on how you're planning to tackle the problem. And I guarantee you your algorithm's going to change as you go through it. You're going to find something that you missed, or come up with a detail or a hitch that you didn't really anticipate. So algorithms are not set in stone. They're just a way to get you started and get your brain solving the problem. There are a couple of videos linked here. I'm not going to play them for you in class. Please feel free to go back and look at them if you want some more details on algorithms and how to build them. But a good example, they have some good examples about sorting algorithms and how you would use, they use laundry and stuff to teach you how to sort things or think about sorting things. Because we just do it. That's something in our regular life that we don't think about sorting the laundry, we just do it. But at some point, someone told you that you separate your whites from their colors, and you separate the red clothes from everything because you don't want the first time you wash it, you don't want everything to come out pink, right? But these are life lessons that we learned over time. But when you start thinking about solving computer problems, you have to think about all the little details that are just kind of common knowledge in your brain. Everybody following? So if I were to give you something like this and ask you to design an algorithm, where would you think you would start? So I want you to come up with an algorithm to count the number of students in the room who traveled out of the state of Georgia over the May break last year. So what's the first thing you'd want to do? Anybody?
Students together.
You definitely have to get all your students together. In this case, I would have to poll all 4 of my sections across online students and the in-person students, right? So then I would have to send out that poll or send out the question, how many of you traveled over the break? How many of you went out of state over the break? Right? So is it starting to make sense? Another example would be coming up with an algorithm to move a robot in the pattern shown below, starting at the X, the robot facing right. Yeah, right. Given the robot can do the following, it can step forward, it can turn left, and it can turn right. So you might start off by listing the steps you think the robot would need to do. So if it's already facing in the direction of this direction, the first thing it would need to do is go forward, then it's going to have to turn, and you have to figure out if it's turning right or left, right? So the first thing I would do, if I had the picture, was I would start figuring out how many times it's going to go forward, whether it's turning right or left. And then I would sit down and code rather than try to code and then erase code and then write code and erase code. We are actually going to do some drawing with turtles later in the semester. So what is a program? It's a sequence of instructions that the computer is going to follow to accomplish a task. Computers only do exactly what you tell them to do. I promise you that the computer is only doing exactly what you tell it to do. No matter how many times you yell at it because it did something you weren't expecting, it did not go out and choose to do something on its own. I'm guilty of this. I yell at my computer a lot when it doesn't do what I expected it to do. But the only person I have to blame for that is me, because it did exactly what I told it to do. Computers are extremely intelligent and extremely stupid at the same time. They absolutely only will follow the instructions they were given. We haven't gotten to AI yet where it's ready to think on its own. So a programmer or a developer is an individual who creates these directions. You all will be programmers by the time you're in this class because you'll have written programs. You're going to be ready for a programming job? Not yet, but you're well on your way. So an individual who writes computer programs or develops software packages is called a programmer or a developer. You'll also see them referred to as coders, software engineers, software developers. There's a lot of different names for the same job. So when we are going to instruct the computer on what we want it to do, we're going to have a program, which means that we have to choose a programming language. In this class, we're going to be using Python. Why are we using Python? What the heck? Oh, okay. Sorry, my computer doesn't like me. The language is really kind of dependent on what you're doing. Python is an excellent, really popular language right now that's easy for beginners to learn. But it's also very versatile and can do a lot of different things. Java will be if you're going to stay in computer science, Java will probably be your next language. Unless you're doing one of the new degrees, then you may not do as much Java. I tried one day to sit down and count how many different languages I have programmed in, and I stopped counting when I got over 10. Does that mean that you have to memorize every bit of every language you program in. No. Once you learn the basics of one or two languages, the others come much easier because they all build on the same kind of structure. It's not like spoken languages. I am horrible at spoken languages. I barely speak English, but I could program in multiple computer languages. And I will mix them up. Guarantee you, in the course of this semester, I am going to mix my Java and my Python. Because they're the two primary languages I use. And sometimes the Java command is going to come to mind, and I'm going to type that, and then I'm going to, oh, wait, sorry, back up. Let's put the Python one in there. Feel free to correct me if I do this. You will not hurt my feelings. Here's Webster's definition of the purpose of the language. Do you have to memorize it? No, it's just good information for you. It's a systematic means of communicating ideas or feelings by the use of conventional signs, sounds, gestures, or marks having an understood meaning. So languages can be written, they can be spoken, they can be hieroglyphs, they can be, as long as they have an understood meaning. It's a way for two parties to communicate. In this case, you were communicating with a computer. And the computer is going to communicate back to you when you run your program. So the purpose of the language, we're going to take those algorithms we wrote and convert them into usable code that will solve a problem or give us a workable model of something. Algorithms are for humans to use. Computer not going to do anything with your algorithm because it's not written in code. Computer does not know what to do with the English language. And there's a very good reason for that. Everybody's like, oh, why can't we just do text to speech and just, have the computer read that? Well, somebody would have to create that program first. And second, oh, notice I got a Southern accent. My English is different than, say, someone who grew up in the Northeast or someone who grew up in the Pacific Northwest, and definitely different than the English of my friend who lives in England. Her English and my English are not the same English. We have a lot of fun swapping slang and colloquialisms back and forth when we talk. She's an American that now lives in the UK. So our algorithms are for me and you, and the programming language is for you and the computer. Language used to communicate instructions to the machine. The code that we're actually writing, the Python, is actually going to get translated even further down into a different computer language. The compiler and the IDE that we're using is going to take the Python and convert it to machine code. And this is where we start getting into those ones and zeros that you see in the matrix and things like that. They don't really scroll across screens that way. There are thousands of programming languages. You guys live in a great time. You have object-oriented coding, and you don't have to go back to procedural line coding that I started off with in the dark ages of computing. So you can reuse code. You can have sections of code that are just completely reusable. I used to have to know what the line numbers were for things and tell it to jump to X line, do this code, then jump back if I wanted to repeat something. That's very tedious, very fast. Yes, I'm old. It's okay. Can anybody think of programming languages besides Python and Java they've used or heard of?
C++.
C++. Yes, ma'am. Scratch is a programming language. It's a visual programming language. It's designed for educational purposes, and it's drag and drop blocks. I've used a lot of Scratch in previous jobs. It's a great place to start with children. and adults too. But I know that they're incorporating that into a lot of the Georgia public education for middle schools. Anybody else? The cloud, it's not a programming language. That's where we store things in the cloud. So we'll talk a little bit about that as we go forward too. There's Fortran, there's Java, there's JavaScript, there's Python, there's Ada, there's C++, C#, C, HTML, COBOL, and that's just the tip of the iceberg. Because originally when programming languages started being developed, they all had an individual purpose. Like COBOL was really good for engineering type processes. Fortran was really good for mathematical, scientific data processing. Now, in modern programming languages, they're more versatile. They can do more things. You don't need a specific language for everything you do. So Python is a high-level language. It's general purpose programming. We are going to use something called an IDE to write our code, but the computer program that we write our code in is going to do that translating for us to something that the actual hardware inside your computer can use. The computer executes instructions on a very simplistic kind of level. It's doing millions of them a second, but it needs to be broken down into very small, teeny tiny steps. So we have our source code. It goes into a compiler or an interpreter, and then the computer creates what we see visually on our screen or what the output we have. Python is an interpreter, not a compiler. I interchange the words a lot, but there are some subtle differences. We're not going to cover that in this course, what the differences really are. That's a higher level concept that you guys will get as you move forward in computer science if you're a computer science major. Otherwise, if you're interested, I'm going to point you to some resources. So that slide should have been taken out. We're going to now talk about the Python programming itself and IDLE. IDLE is the name of the IDE or the individual developer environment we're going to use. Computer science has a lot of acronyms in them. I promise you at some point I knew what all of them stood for, but sometimes I don't always remember. So alphabet soup. So if you're on the computers in front of you or you're on your personal computer, I don't care either way. You can bring your laptop to class or you can use the lab computers. We're going to use IDLE to do all our coding. IDLE is free. You can download it at home. You can download it to your laptop. It gives you a place to write your code and edit it. It'll also run a debugger program. So if you type something wrong, it's going to catch some of your errors. Then it builds it in the background with the machine language, and then you can execute it and see what you coded. Do you have to do it in the IDE? No, you could do it in a notepad document, compile it through a different way, but you miss out on those debuggers and you miss out on the things that help you catch errors. So this one has a text editor. I had it open. We'll look at it in a minute. So if you're on these machines, it's already installed. It should be working beautifully and no problem. If you're in the labs, it should be working beautifully. We also have given you access to a VLab or a virtual lab. So if you're on a tablet or a Chromebook and you can't get it installed, you can always log into the VLab and do everything that way as a virtual lab. There is a text editor. There's going to be a place where you can type code. It will highlight syntax errors. So if you misspelled something or you left the punctuation or something out, it's going to catch some of that. Not all of it. It's only going to catch misspellings if it's a Python term. It's not going to catch it if it's something you're using as a variable or regular English. The debugger will let you run it and watch what the computer is doing kind of in a side window where you can try to follow along and see where you went off the rails. So our first Python will be lab 1. We'll work through it and discuss it in class at our next meeting. I plan on doing the entire lab with you because I want you to get a good feel for it, start off on a strong footing with your first coding, build some confidence. Some of you have never coded before. I want you to leave our next class period feeling like, yes, I can do this, and not be frustrated with your first attempt. So code's going to look a little bit like this. This is very, very simplistic code. But we are going to do some very basic coding next class. I want to show it to you today. You're welcome to go home and do this on your own if you want to. The assignment's already out there. But a variable in programming languages is very similar to a variable in math. So you've been in algebra, college algebra, they talk about X and Y variables. Variables in computer science are very similar. It's a placeholder or a place in memory that's going to store data. It can be words, it could be numbers, it could be just about anything you can think of as far as data. It's also, by very definition of the word variable, something you can change. One way you can think about it is if you think about moving and you're moving your house and you have to pack up everything you own, a variable could be a box. Think of it like a box. You're going to write on the outside of the box what's supposed to be in it, and then you can put stuff in the box. That box, in this case, is a memory location inside of your computer where that information is going to be stored. You are going to give it a name where you can get back to that information. Because if you store information and you don't name it, you have no way to retrieve it. So you could theoretically box up your entire house and never label any of the boxes. But you're going to spend a whole lot of time sorting when you get to the new location. So in this case, the variable name, once you create it, isn't going to change. You can delete the whole thing and get rid of it, but you're probably not going to change it. Well, actually, you aren't going to change it, because if you change the variable name, you actually have created another variable, because the names are very specific, and any change in it just creates a different place. So if I had make and make one, they're two different places in your memory. So in this case, we're talking about the make of a car, so we would put Ford in. Python is case sensitive, so make with all lowercase letters is different than make that starts with a capital letter. So we have some conventions we're going to use as we move forward. And variable names are always going to be lowercase. Very few things in computer programming languages start with capital letters unless there's special cases or part of the programming language itself. And there's a reason for that. It makes it more readable. It should be able to pick out important things. So all of these variables are lowercase. So this variable is storing a string of characters, and we'll get into more details about strings as we go forward. This variable name is actually going to store the result of this function call. It's going to go and get input from the keyboard, in this case, that the user is going to type in. So the user is going to see on their screen, enter your name, and whatever they type in after that, until they hit the return key, is now going to be stored in name. Now, if they are good users and they follow directions, they're going to put their name there. If they're not good users and they didn't follow directions, we don't know what they'll put in there. Age count are both storing numbers. I have age here and I have age again later. So age appears here and then it appears again here. What happens is if you use age a second time, the new data overwrites the old data. So now age has changed from 22 to 23. So maybe they had their birthday, or maybe they are correcting a mistake. But you can change what's in the box. Once you've overridden what's in the variable, you can't get the old data back unless you saved it somewhere else. Am I blowing your mind yet? All right. Temperature is going to store a decimal number. So all sorts of data can be stored in variables. You're going to be using variables a lot. There's just no way around it. Every program is going to have variables. Of course, now one of you will go and find a way to write a program without any variables in it just to prove me wrong, which is great because that means you're thinking and you're being creative, and I'd love to see it. So there are some naming rules for variables. You cannot use a space in a variable name. So if you want a variable that's total students, you have to use the underscore character instead of a space, because Python sees the space as stopping that word or that variable name, and then the next one would be is looking for a different command or a different piece of information. So no spaces between compound words. Total students with the underscore is absolutely allowed. I highly recommend that you use variable names that are meaningful. If your variable is storing the user's age, call it age. Don't call it X, don't call it Y. Call it what it is, because you have the opportunity to write it in. Why am I telling you this? Because 6 months from now, if you go back and visit this program, you won't remember what X, Y, and Z were. Especially if you've used hundreds of variables inside of the program. Years ago, I used to teach computer science to high school students. And I had a student that played competitive Pokemon. He made lots of money competitively. I snickered too until he told me how much money he made a year. To annoy me, he decided to do his final project, and every variable name was a Pokemon character. He didn't, but I have never played Pokemon, so I had no idea what the beyond Pikachu. I couldn't tell you who's in Pokemon. So this was fine as long as it worked. But when I had to go in and troubleshoot something, I had no idea what I was reading. I did not realize there was that many characters in Pokemon, but there's a lot. Do not ever start a variable name with a number or an underscore. Variable names should always start with a consonant letter. No symbols or numbers. If you are doing like class average, it is definitely more readable with the underscore in it instead of writing it all together as one long word with no spacing. A convention is suggestions, very strong suggestions for you. There's no way for me to truly enforce that because it will still work if you don't follow conventions. I will tell you, if you move forward in computer science, that they will start grading you down if you don't follow these conventions. So let's learn good practices now, rather than you get into an upper level course and they start, trying to break bad habits. So there's two types of errors commonly seen in computer program. There's logic errors and there's syntax errors. Logic errors are really hard to find and identify because that means that your thought process wasn't on target. Syntax errors are the things that the idle programmer are going to help you find. So syntax errors are like, in this case here, I guess I should, the first example here, names equals input, and you have the command again. The difference here is this time the user, when they typed it, left the closing parentheses off the end. That's something that the idle program will be able to catch for you. It'll put a little red squiggle and say that there's a syntax error here. Is it going to be overly descriptive about what the syntax error is? No. Sometimes it'll be nice and say missing paren. A lot of times it'll give you a cryptic warning that there's something wrong on this, but it will tell you what line and you can go back and look for it. And I'm going to tell you the truth. You're going to be frustrated with syntax errors quite frequently because if you're like me, you don't type perfectly every time. And my spelling's horrible. I can't tell you how many times I will misspell a variable name. It's great if you consistently misspell it, but if you don't, there's no spell check for that. It just creates you a new variable named whatever the misspelling was. Semantic errors or logic errors are much harder to find. That's where you and I will probably sit down and go through some code, and I'll use my experience to try to track it down. We'll put some lines in to print out to the screen just where we can see what is going on, but we'll have to narrow down where it's broken. So that's all I have as far as new content today. We are in the next class period going to do lab 1. It is already posted in CourseBin. If we have enough time, I might get you started on assignment 1 also, because this first labs are pretty short. Anybody have any questions before I cut you guys loose? Yes, sir.
In question, it says install Python 3.8.5.
Yes. The directions are old. Install the newest version of Python. I need to update that. So if you get in there and it says install 3.8, whatever, go ahead and install the latest version of Python. It just means that they've done upgrades since I've typed my directions. Yes, ma'am.
So while you were talking about I think and every time you or like it's if you make a mistake you can't go back.
Absolutely can't go back.
Okay.
Absolutely. So I'm going to tell you, you are going to make mistakes. Your code is very rarely ever going to work the first time you run it. I've learned my greatest lessons in coding sometimes with my greatest failures. Do not be afraid to try something and see if it works. Do not be afraid to have it fail, because we learn a lot from our failures. And it's not really a failure, it's a learning experience. Again, also, never think there's something you can't ask me. The only dumb question is the one you didn't ask me, and it shows up on the next exam. I will bend over backwards during lab time and office hours to give you as much help as I can without doing it for you. I will not write your code for you, with the exception of some of the examples I'm going to do, and you're welcome to copy any of the examples I do. Any other questions? All right. Well, I'm going to cut you guys loose. Class usually doesn't end until what, 9:15? I'm going to cut you guys loose for today. We will do coding at the next class section. If you run into any problem getting idle installed and working on your computer, drop me an email or swing by my office hours.